Hi everyone. Today, instead of solving algebraic and geometric problems, we're going to be taking a break from that, and today we're going to be discussing some trigonometric formulas. So we're going to be talking about a couple formulas, and after we're done, we're going to solve a couple questions related to the formulas, and we're going to discuss on how we got the answer and how to simplify things more. So let's go ahead and get started. So the first trigonometric formula we're going to talk about today is sine x plus y. So this gives us the answer as sine x cos y plus cos x sine y. Now, before we dig deeper, I'd like to point out how we have switched up the order of identities. So if you notice, over here we have sine x first and then cos y, but over here we have cos x first and then sine y. And the reason behind this is so that we can identify an identity and so we can identify a formula quicker and easily, so we can substitute a formula. So if that doesn't make sense, it's in simpler words, it's only because so that we can see the x and the x together and the y and the y together to make things easier for ourselves. So the next formula we're talking about is sine x minus y. So this gives us a result. Well, if you think about it, it's pretty much the same thing as sine x plus y. The only real difference over here is that the first one has a plus and the second one has a minus. So, well, it's pretty obvious that the answer is going to be the same thing, but instead of a plus sign, we're going to have a minus sign, which is exactly what I'm writing down here. So, again, both of these are the same except they have the difference of their signs. So the next formula we're talking about is cos x plus y. So cos x plus y is a little bit more complicated because the thing with cos x plus y is it doesn't have the same signs as in the brackets. So if that doesn't make sense, I'll show you what that means. Cos x plus y gives us cos x cos y minus sine x sine y. And if you notice, it looks kind of weird because over here we have cos x plus y, but over here we have a negative sign. So that is something that can throw you off track, but I'd advise you to make sure you don't make this mistake while writing down formulas. So the next one we're talking about is cos x minus y. So again, the only real difference is in the signs, and instead of a minus sign, we're going to have a plus sign. So cos x cos y plus sine x sine y. Now, the next couple formulas are slightly trickier because they can be written in multiple ways. So the ones I'm talking about are tan x plus y. Now, I'm pretty sure you're familiar with the idea of tan x being the same thing as sine x over cos x. So that means that we should, So if this is the case, then that means we should be able to write tan x plus y as sine x plus y divided by cos x plus y. So if we simplify that, we can write it down as sine x cos y plus cos x sine y. And cos x plus y would give us, well, cos x, cos y, minus sine x, sine y. But there is another way of writing this down. So instead of writing this whole thing over here, we can simplify it and we can write it down as tan x plus tan y divided by 1 minus tan x tan y. So this is the same thing as the term we have written before. So next, well, and our last formula is going to be tan x minus y, pretty obviously. So tan x minus y. Let's go ahead and solve this formula. So again, we can write this down as sine x minus y divided by cos x minus y, which would give us, well, sine x cos y minus cos x sine y divided by cos x cos y plus sine x sine y. But again, this is the same thing as tan x minus tan y divided by 1 plus tan x tan y. So again, this is the same thing as what we have written here before. And, well, this is our last formula. So we've discussed all the formulas, but let's go ahead and try solving a couple questions which involve the use of these formulas. So the first question we have here is, well, we need to prove that cos 5x cos 3x plus sine 5x sine 3x is equals to cos square minus sine square. Cos square x minus sine x squared. So to do this, first let's look at, well, the left-hand side of the equation. So that says cos 5x cos 3x plus sine 5x sine 3x. Now, if you look at this closely, you can see that this is in the form cos x cos y plus sine x sine y, where x is equals to 5x and y is equals to 3x. So if you look at this formula over here can be simplified and written as cos x minus y. So that means we can write this equation in the form as cos x minus y. So let's go ahead and write that down. That would give us cos 5x minus 3x, which would equal cos 2x. Now, cos 2x is not the same thing as cos square x minus sine square x. So how do we simplify this? Well, we can write cos 2x as the same thing as cos x plus x. And using the formula we just discussed before, we can write down cos x plus x as cos x cos y, which is x, minus sine x sine y, which is again x. Now, if you look at it closely, cos x times cos x is the same thing multiplied by itself, which is the square of its number. So that would give us cos square x minus sine square x, which is the same thing as cos square x minus sine square x. So that means we have solved this question and we've proved it. So now let's go ahead and solve our second question. So this is our second question. Now, looking at it, you might think this is a pretty easy question. It says sine pi by 2 plus alpha minus beta is equals to cos alpha cos beta plus sine alpha sine beta. And it may seem pretty easy, but then when you take a closer look at the left-hand side of the equation, you'll see that it has sine pi by 2 plus alpha minus beta, which has 3 terms in the brackets. And we've only learned how to solve sine alpha plus beta when it has 2 terms inside its brackets. So how do we solve this question? Well, what we can do is we can write down this, we can take x to be pi by 2, and we can take y to be alpha minus beta. So this way, we can write this down as, we can write the left-hand side of the equation as sine pi by 2 plus alpha minus beta. And in this sense, it only has 2 terms in its brackets. So then we can simplify this and write it down as in the form of the formula we discussed before. So taking x to be pi by 2 and y to be alpha minus beta, we can write this down as sine pi by 2 cos alpha minus beta plus cos pi by 2 times sine alpha minus beta. Now, one thing I'd like to note is that pi by 2 is the same thing as 90, and we know the value of sine 90. It is 1, so this is 1 times cos alpha minus beta. So we can go ahead and write that down. And then we have cos alpha by 2 times sine alpha minus beta. Oh, my bad. We have cos pi by 2 times sine alpha minus beta. Now, we know the value of cos pi by 2, and that is cos 90. And cos 90 is the same thing as 0. So this is cos 90 times 0 times sine alpha minus beta. So then we have cos alpha minus beta left. And 0 times sine alpha minus beta, well, whatever it is always 0. So this would be cos alpha minus beta plus 0. And now the plus 0 doesn't really mean anything, so we can go ahead and simplify this. So we have cos alpha minus beta, which is the same thing as cos alpha cos beta plus sine alpha sine beta. And if you look at the start, that is exactly what we had to prove in the beginning. So if you look at it, we saw this question. So thanks for watching this video, and I hope that you're walking away with a little bit more knowledge about trigonometric formulas and how to solve a couple of these questions. So if you like this video, be sure to check out our channel. We have lots of amazing content out there, and we upload daily. So thanks for watching.